Hi everyone, and welcome to this AMS Automotive Evolution live stream with me, Christopher Ludwig, Editor-in-Chief here, where we're talking about how EV powertrains are transforming automotive production and indeed the automotive supply chain. You can't turn on the automotive news today without it being charged with news about investment in gigafactories, about prices in the battery supply chain, around new regulations and targets around electrification. We are seeing a massive shift, of course, in the entire scope of the automotive industry, and at the heart of it is the battery, and that sits, of course, at the heart of the powertrain and all the production that's going into it. We're seeing some massive changes, and that's part of what we want to talk and share with you today. With some entrepreneurs in the sector, with some analysts sharing some great data, and hopefully having some fun along the way. So just to kick us off again and share a little bit of the context with you, as mentioned, battery demand is driving huge investment in gigafactories, manufacturing, supply chains, and in many new dimensions when we talk about the automotive supply chain and production sector. We're seeing the global footprint of battery cell production expand, traditionally from Asia, China, increasingly in Europe and North America, and a focus on regionalization. And what we're also seeing is a lot more focus on the upstream, transparency in supply, the security of supply, and the price of raw materials and energy. That, of course, all has been severely exacerbated by the Russia-Ukraine crisis, as we'll speak in more detail a bit later. And it means that OEMs themselves are a lot more focused on this part of the supply chain and on manufacturing than perhaps they would have been previously. And what that sort of translates into is we see more variety in supply contracts across manufacturers and cell suppliers, but also a lot of focus on the chemistry mix, both in consideration of what the supply looks like for materials like cobalt and also the cost for lithium and nickel. We've seen some significant news just in the past couple of days, for example, from both Ford and General Motors on the chemistries and contracts that they're supplying for the next, or they're securing for the next couple of years. Joint ventures between OEMs and cell producers, as well as vertical integration from the likes of Volkswagen and Tesla. And that upstream, that joint venture and investment is extending upstream too. So we'll see companies like GM partnering directly with POSCO, for example, and taking a much more active role in that supply chain. We can make a parallel to the semiconductor space, for example, where previously kept at a remove. When the supply has gotten tight, obviously now we've seen a lot more focus upstream. I think OEMs are learning from those lessons early on. And energy and renewables, the power needed to supply these gigafactories, the emissions and energy needed to produce these batteries, a lot more focus than we've ever seen before, of course, as a result of net carbon targets, but also that cost of energy, which we'll come back to again and again. The powertrain itself is also, let's say, being reshaped, and certainly the partnerships across it as well. So we're seeing shared platforms being used across OEMs, whether that's GM and Honda, OEMs partnering in different areas of powertrain development and production related to electric motors, housing, power electronics. It doesn't make sense for every OEM to maybe invest in all of these or to have their own production space for all of these, so they work with a variety of partners. Battery startups, of course, are also partnering with tier ones in parallel for manufacturing, for R&D, for testing and capacity. And that, of course, speaks to one of the key topics for today as well, which are those partnerships which are needed to scale up production. Again, in the chemistries, in things like automation design, factory and layout, testing and validation, and as we'll come to, recycling of materials and the circular supply chain. And that, of course, all speaks as well to the focus of capital investment. How do you make manufacturing these batteries competitive? And indeed, where will the competitive advantage really lie? Will it be with the battery and the battery technology itself, or will it in fact be with the supply and manufacturing of those batteries, or will it be both? So that's some context, and I think we've got some really exciting experts and expertise and data to share with you today. Before I do that, I wanted to just highlight again, fresh off the digital press here, the latest digital edition from AMS, which has indeed some more insight on EV and battery manufacturing. There's a link being dropped in the chat now, so please do access that when you have a moment and dig into more of our content. But now what I'm excited to do is introduce our guests and experts who will be sharing insight today. And the first I'd like to introduce is Lars Khalsam, who, as I mentioned, is an entrepreneur who is founder of, I'd say, a series of gigafactories now. It did found British Volt, although not involved with that anymore. Has founded and is building up a gigafactory in Italy, in Italvolt, and has more recently founded a startup in the US, State Volt, to build a gigafactory in California. Lars, great to have you with us. And with those exciting adventures, which I don't think you've chosen those locations just because they're sunny and lovely wine regions. I think there's quite a lot more behind it, right? So really excited that you can come here and share some insights with us today.
Thank you, Chris. Thank you, Chris. Yeah, that's true. I mean, it's for sure it's nice with sun and good wine, but it's not the prime reason. We are actually also choosing our sites from another perspective. We also look into the social impact and preferably build our factories in areas in decline where you can actually make a big impact and a big change. And that's why we've also been choosing Scarmagno in Italy, which is an area which was very prosperous until 1992, when Olivetti ceased and closed their business. And so that's certainly needed in that part of Italy. Even if you are in the north, it's still been in decline and suffering hard. And also what we're doing in the US is the similar thing in Salton Sea, where you also see a similar scenario.
Great. So the preview, we're looking forward. We're going to drill down to some of those topics with Lars and take some of your questions as well in the audience. Remember, you can put any questions through the chat function in the control panel, which you'll see. Before we talk more with Lars around Italvolt and State Volt and indeed battery gigafactories and production more broadly, I'm also very excited to introduce my colleague right here, our own Daniel Harrison, who is with me here in our studio today. Daniel Harrison is our automotive analyst and our resident battery expert. I've been calling him Mr. Battery now for a better part of 2 years. I think he tolerates it more than likes it. But Daniel is been an automotive analyst for more than 10 years, focused across many areas of technology and the value chain, and really has done a lot on the battery side, and in fact has an exciting new report which we're going to share with you today, make available. It's just literally published today, and we've got some data and highlights from that. So we're going to do, Lars, we're going to bring you back in about 10-15 minutes after we've heard from Daniel, so looking forward to connect with you then. I'm going to hand it over to you, Daniel, to talk to our audience and share some of this great data, and we'll pick up with some Q&A afterwards as well.
Yeah. Thank you, Chris, for that great introduction. So now I'm going to talk through a very brief 10-minute or so summary about the report that Chris mentioned that you can now download from our website, just published today. You can also download these slides from the handout in GoToWebinar. So that's available right now. So I'll start off with the context, of course, which is the move to electrification. The reason I'm starting for this is very simple. So we're forecasting globally that there's going to be about a 20% annual growth rate in electric vehicles. And people mostly assume, okay, well, you need a corresponding growth rate in the battery supply chain. Well, it's not quite that simple. If you look at the issues around battery supply chains, for example, per EV, the battery pack is gradually increasing in size because their costs come down and the expectation of vehicle range goes up. We're predicting that the average battery pack will grow from about 60 kilowatt hours currently to around 80 or 82 by the year 2030. So not only unit volumes increasing, but the battery pack also increases. There are also other reasons why the battery supply chain actually needs to increase at a slightly faster rate than pure EV volumes to mitigate against supply chain disruption. There's also questions around the fact that there is no single lithium-ion battery. It's not commoditized. There's a multitude of different chemistries that are used. There's a multitude of different cell formats that are used. So for OEMs, it's not possible just to switch from, say, LG Chem to Panasonic or BYD or SKI batteries. They may be different formats, different performance, different price, different cost, everything. So that's why the battery capacity globally has to be well above EV demand. So you can see from the orange line that currently there appears to be quite an excess of capacity, and people have rightly questioned, okay, why that is. It's based on stated plans of investment for growth in these gigafactories. Often it will be a case of there'll be several different phases to those gigafactories. You know, they'll open up a plant 2 at that site or expand it, but it does depend on those plans actually coming to fruition. And of course that depends on EV demand, so it's somewhat chicken and egg there. But at the present, it looks like gigafactory production capacity looks to be largely in excess of demand, and that's an important factor to understand, because what we're seeing is the restraint is actually likely to be in the upstream. So let's look at the upstream. So we know that, for example, lithium and cobalt are 2 of the main elements used in EV batteries, and they're primarily sourced from Asia Pacific, South America and Africa. And of course the recent spikes in prices that you can see there have been triggered by the Russia-Ukraine war and conflict, creating supply chain shortages. There's also the factor around the EU battery regulation, which is likely to come in, which has rules of origin and sustainability criteria attached to it as well. So likewise with nickel and manganese, they're heavily located in Asia Pacific and Africa. We've seen a spike in nickel prices in particular, less so for manganese though. The factor there though is that the high purity rate of manganese that's required, the automotive grade of the element, is only produced by a few suppliers. So there's relatively few suppliers for that element. Now, these price spikes, these shortages are leading and driving OEMs to form supply agreements upstream with these suppliers. Almost all of the OEMs have done this with multiple suppliers, so supplier diversification. So this is what we call sort of semi-vertical integration. They don't own the companies, but they have very strong supply agreements with them. If we look at the midstream, so this is the battery components, the cathodes, the anodes, the electrolytes, the separators, and also the copper foils that are used within the battery manufacturer. This is heavily focused in Japan and China. I would estimate 90 to 95% of global production is in that region. So this is actually the element of the battery supply chain which is likely to be very difficult to regionalize to Europe, North America and other regions. If we look at the downstream, the gigafactories, we're forecasting that the current capacity will grow from 959 gigawatt hours to over 4,000 by 2030. Currently, it's dominated by China, with about 73% in Asia rather, and Asia will continue to lead the global picture by 2030, but it will be more evened up. Europe will nearly catch up with about 1,450 gigawatt hours, and North America in 3rd place. But noticeably, there's virtually nothing in South America or Middle East or Africa. It's very much focused in those 3 regions so far. Other factors are that if we look at the top 10 battery cell suppliers, it's increasingly consolidating, and that's because the main suppliers such as CATL, BYD, LG, Energy Solutions are massively expanding compared to the relatively smaller players. So it's heavily consolidating around those players. In fact, I think the top 5 companies currently have about 60% of the global production capacity. we look at the battery integration, now this is increasingly an important area of focus because there's a lot of competitive advantage to be had by the way that the cells are formed into modules and then formed into battery packs with the battery management system, the thermal cooling systems, the casing. We've seen a lot of innovation in this area in terms of cell to pack technology or even cell to chassis technology. So there's a lot of advances in this area, and this is a critical area which is increasingly being regionalized or even hyper localized to vehicle assembly plants, because OEMs realize the competitive advantage they have by keeping this very close to their assembly plants. They can have more influence and control over that. If we look at the key findings, so the automotive supply chain is going to be synonymous with battery supply chain strategy. This is OEMs, as they expand EVs production, it's going to be critical how they handle and develop the supply chain there. So we're seeing a lot of investment in that area. Now, there's big rewards to be had, but there's also risks. I mean, it's a very strong area to grow in, but there's risk induced by the price spikes that we've had recently. Nonetheless, it's going to be a great area to invest in, but we have to be aware of those potential pitfalls. Building the supply chain resilience is going to be absolutely critical. We've seen in the last few years the ongoing disruptions that have highlighted the importance of supply chain resilience. The visibility and tracking of inventories is absolutely critical to success. In fact, it's going to be a competitive advantage because keeping inventories at correct levels will allow OEMs to fundamentally sell more of their vehicles. But it's critical for the whole supply chain to be expanded, not just at the gigafactory level. As we said previously, it appears that there's plenty of gigafactory capacity at present and for the foreseeable future. But the upstream is going to be a real challenge, in the midstream as well, developing that. And also don't forget about the recycling part of this, the whole value chain. That's going to be increasingly important to supplement shortages in the upstream. And governments play a critical role in all of this. We've seen the recent news around potential government loans to cell companies and OEMs, with, for example, with the Ultium joint venture between GM and LG Chem in the US. The LG Chem's Poland plant in Wrocław also had a government loan, I believe, of about 480 million euros from the European Investment Bank. So these are critical factors in this. And also this sustainability regulation is going to be crucial in driving and regionalizing the battery supply chain. So in terms of the implications for manufacturing, the main one is going to be complexity. So yes, ultimately, electric vehicles have fewer moving parts, which will simplify supply chains. But until we reach that point, we have this transitional phase where there's going to be a huge variety of powertrain variants, often produced on the same production line. You know, you're going to have hybrids, plug-in hybrids, electric vehicles, and all of the range in between. So that actually increases the number of parts, the complexity of supply chains, and the complexity of operations there. And that's going to drive more modular, more flexible, adaptive manufacturing techniques to be able to cope with those huge number of variations and potential technological advances which are likely to be made in battery technology in particular. And automation and robotics are going to be critical as well in that transitional period to not only achieve the economies of scale, but to reduce the costs, to reduce the labor costs of battery production and assembly. And we're going to see strong partnerships and collaborations. We've seen that with many joint ventures between OEMs and battery cell suppliers, but also across the supply chain between tier suppliers, cell suppliers, and also upstream supply agreements, as we've seen. Sustainability is going to be a key theme as well, because you know, the focus has shifted from tailpipe emissions of vehicles, which EVs clearly deals with, but then the whole shift to looking at the whole carbon footprint of the whole production cycle, and we're seeing that being addressed across the supply chains in terms of production, in terms of energy use, materials, etc. And the regionalization and localization is increasingly going to be a major factor in that. Reducing the logistics cost, the transportation of EV batteries across the world from Asia to the West made sense at low volumes rather than establishing a localized supply chain. But as volumes ramp up, increasingly that will have to be localized to reduce that carbon footprint and achieve those sustainability goals. But ultimately, that's going to be a slow process. We can't change these locations quickly overnight. It's going to be a slow, gradual process. So that's the presentation. As we said, the report is available to download on our website. And I'll now hand back to Chris. Thank you very much.
Well, thank you, Daniel. As ever, tremendous insight there and packed full of data, and obviously lots of good news in there, but clearly highlighting risks as well. We put a link in the chat for everyone, so if you can download that report directly, and as Daniel mentioned, you can download the slides right here on the platform. So that's in the handout section of your control panel, probably on the right if you're on a laptop or a desktop. Just scroll down to handout and you can download those slides. We'll also put them on the website afterwards when we make this whole session relevant on demand. But Daniel, for now, I'm going to thank you. I'm going to bring you back in a little while to join a panel discussion. Okay. But I want to now bring Lars back to get some direct insight and talk a little bit more specifically around your projects there, which we started to address as well. Lars, great to see you again. So there we just heard obviously the broader context from Daniel, and I think, you know, we're in a climate, clearly, as everybody is more than aware of, inflation, economic uncertainty, energy prices which are rising and rising, especially here in Europe. How would you broadly characterize the landscape for, you know, the let's say the gigafactory side of this supply chain? Clearly, as someone who's, you know, building up too, is it becoming tougher to gain partners, financing, to move these forward, or in fact is the rationale becoming even stronger?
Well, for sure, from announcement to reality, it's a long way, and I would say that we are in a new green industrialization, and I think this space in this downturn will be probably one of the few investment areas which will still be valid after I foresee serious difficulties in the autumn and the winter. And from that perspective, I think we are in a space where it still will be a lot of attention and interest, because we are in this space. You have both governments and private equity are fueling funds into it. And if you would like to see this change happen, it's also a need. And I see difficulties also in the supply chain. Yes, they could be overcome. They will take some time, and as also mentioned here, probably the only one who can change this, as we have 95% of all rare earth minerals in China. It takes a lot of support from governments to change this situation, and they are probably the only one who can do it also. And but I think the biggest problem we have is the energy, and to source green energy and find the right energy resources. I think that's the most challenging part. I mean, also our factory in Italy will probably consume up to 1% of all energy in Italy. So we also need to look after how we are sourcing our energy, and there are a number of opportunities to be a part of it. I mean, we are also being forced into situations where we also need to take action and look after the situation. I mean, I'm talking about where can we find this energy besides from tapping it from the grid. I see also in Italy we have a huge opportunity for geothermal energy, a number of areas which hardly hasn't been explored in Italy. And so therefore it's a lot of things that's going to happen, and also will change. Everything will change. That's the way I see it. I see also this downturn now coming is going to change all our lives. And this is just what we are doing is a part of a new beginning.
That's a pretty remarkable statistic you just said there, that eventually, you know, the factory would consume 1% of energy across Italy. So I think it gives us a sense of the scale of energy consumption that goes into that, the potential emissions, why that needs to be addressed from a holistic point of view. If we're talking about a green battery, then it needs to be greener in its production, but also those cost factors, obviously. So I want to just pick up on that point a little bit around the potential for green energy to supply an operation like that. What kind of timescale would you imagine that needs to happen? Because you're looking to come online, or at least begin production 24, 25. And then ramp up. I think 45 gigawatts is the planned capacity in Italy, and we can come on to Statefold after. What sort of transition period would you envision needing to reach that kind of goal?
I clearly see that when we are in a production start in maybe early 25, I can see that we're probably missing out on some space of energy that we need to still continue working on. I'm not sure that we were able to fulfill the commitment of being totally green on energy in 2025. I clearly also see that in the case of Italy, 40% of all natural gas comes from Russia, and that's something that we would like to change. And so therefore, I see also this will also bring opportunities. I mean, in Italy, we have one of 7 supervolcanoes. But we also have restrictions in terms of permitting and these areas, which has to be changed. I mean, I think Italy can be totally independent on energy if they are working on these areas, and the whole country can be supported by geothermal energy. That's the way I see it. It's a huge opportunity for a country like Italy. And also I see that Italy has been in decline, or has been having difficulties for many years, and the opportunity they now have to be a part of this new green space is massive, and it's going to be extremely interesting. And if they are now grabbing this opportunity, they could easily become one of the leaders in Europe in this space.
Some tremendous opportunity there. Obviously, some volcanoes to scale first, but those are indeed part of the opportunity. I wanted to turn a bit to what Daniel referred to, obviously, in the raw material upstream. You also just obviously mentioned the dominance of China in certain regions for some of these inputs. Firstly, on the price volatility that we've seen and continue to see, does it change for you? Does it change the business model for battery production in any ways, compared to even where we were, you know, let's say February 20th, 2022, or whatever the signal point might be?
Yes, it's a dramatic change, and for sure it will affect how the business model will look like. And it's also a bit hard to predict. We just need to follow right now and try to understand. I think no one really have a clear picture on where we are heading right now, and we can just see that the costs are escalating in a number of areas, and for sure that will affect how these factories will be built, and also we need to refine our engineering process and try to cut costs in this process, and to make we are also now eyeing machineries which are significantly reduce the scrap, and that will also save us a lot of money. And these kind of things can also compensate higher raw material costs if we can do this in an even more proper way. So that could also have a huge impact on the business.
One of the objectives that we see, certainly from governments as well, and increasingly in focus from OEMs too, is clearly regionalization. Regionalization of the gigafactory in cell, that is relatively clear, as Daniel laid out. The bigger challenge probably is upstream, and we look at things like mining of those materials. In Europe, that seems to me like it would be a 10-year horizon, I think. I mean, in terms of any meaningful gains in that. In the meantime, are there other things that can be done to mitigate the risks that come, you know, again, in this transition phase over that launch production over the next 5-10 years?
Yes, I mean, to recreate a supply chain for the battery industry in Europe will take time. And clearly, there are announcements also. I mean, UK have a target of 2030, which is not realistic. It will not happen. It will take a lot longer. I think 2035 is still a huge challenge. And we're going to see, I mean, in Europe, we produce 18.6 million cars. Our factory, which is huge, is massive, it's one of the largest in Europe that we intend to build. It can produce battery cells for 550,000 cars. And if we all go electric, which is 18.6 million cars, you need a number. You need 20 of these factories, 30 of these factories easily. And depending on how you can build these in a more efficient way. And so therefore, it's a huge investment. And then recreating a supply chain who can support this massive change from combustion engine to EV is going to be extremely difficult and challenging. And I foresee that we will have a transition period a lot longer than we expected. I can see also clearly that e-fuels will play a role. There will be a number of areas where actually we will help the transition to go fully electric. But to be fully electric like in Europe with 18.6 million cars going electric, it will take a very long time. We had spent more than 100 years with the combustion engine, and this is nothing that we change in 5 to 10 years. It's a very naive view on the situation. That's the way I see it.
So definitely some realism, the dose of realism there around the targets and even regulations, let's say, that are being legislated in. But if I turn to the US and the approach that you're taking there in California, I mean, there you're aiming for an on-site supply of lithium, if I understand correctly, with a partner there, with the CTR controlled thermal resources. Talk a little bit about that. What are the innovations that are required? Is this a vision that, you know, it's a great vision, but is a vision that obviously will need some transition and other steps to get to something so hyper-local, as we might call it?
Yes, it's a fascinating narrative for sure. I mean, it's the site that we have been choosing there. It's in Salton Sea, and it's one of the richest areas of lithium probably in the world. It's massively rich of lithium, and also of geothermal energy. And these are two areas we can actually, so we can recover both lithium and energy. For sure, we need to transfer into cathodes, but I mean, so there are still some parts missing in the supply chain, but can be added at site. So it's an amazing story and amazing opportunity. I think this is the only gigafactory project in the world that can actually say that we can digest our own lithium and energy at the actual site of the factory. So that's an amazing opportunity. And we also, when we launched this, we had the Secretary of Energy in the US visiting our site, and they are paying a lot of attention to this. And clearly, America is probably a year and a half, maybe even 2 years behind Europe in this process. But in the way they're now fueling funds into this, I can clearly see they're going to pick up very, very soon.
Yes, and then, you know, holistically, we see a lot of activity as well upstream in Canada and places like that too, to support this growth. If we look at some of the other partnerships that you and with Italvolt and laterally also with StateVolt, I mean, and one recent one that I believe has just been spoken about is with the university, and specifically on looking at recycling materials. Correct, and Daniel referred to that will become more important. So how much of an impact and how relevant, how important will the recycling of the materials you're consuming be, again, in this ramp up phase, and how quickly will that become critical?
Yes, for sure. If you see on the market, we don't have much batteries to recycle yet, as we don't have an EV fleet, and the batteries on the market, they are still in function. So they are working very well and servicing the owners of the EV cars. Clearly, what was coming now, when we are in production, there will be some scrap, and that has to be recycled. So we also have designed a recycling plant within the gigafactory, so we can digest the scrap at site and recycle it. And as we also need the minerals, so therefore it's a good way for us to recycle it immediately and put it back into production. But they're also something that we are working on the machinery and find the right equipment so we create less scrap and less need for recycling for sure. But it's an important ingredient for us to have at site.
Great. When we've spoken previously, I think you've also mentioned to us how the idea of vision for Italvolt is to partner as well on the R&D technology of the battery, and for Italvolt to therefore focus more effectively on the production, on scaling the production as a kind of IP. Are you closer to establishing those partnerships than you were previously?
Yes, we have a joint venture actually at the table currently, and this gives us a fast charging technology together with a base technology. And we are also in talks with serious offtakes with major OEMs, and which can also be a part of the process going forward, and also will be able to support the process for us in the final engineering phase. So we're quite well furnished, and it's an exciting time for us. And we clearly see it's been, I cannot say it has been easy, but it's certainly been rewarding. And we are in a phase now where we can clearly see this going to be very exciting autumn and winter for us.
Absolutely. And so that partnership for the technology is close with a joint venture. Could you also imagine partnering with other types of suppliers and manufacturers on other aspects of let's say the complete battery and powertrain, be it in the housing, the pack, the module, the systems? You know, as we talked about with Daniel on that side, is that also something that is in focus for you?
Yes, I see the whole industry is firstly, I don't see that we have competition, because there are no competition, as the demand is so much higher than the supply for the next 15 years. So it's not a direct competition scenario. So I think we all need to collaborate to make all this happen. And that's something we discussed also previously here regarding the timing of when can we go all electric. And if we all collaborate, all gigafactory projects, governments, institutions, supply chain, it all has to be involved in the process and be a part of it. So we are very open to collaborations and finding solution with others. So it's, for us, it's a given. I mean, we are really keen on collaborations. We like that a lot.
Yes, and I mean, one of the other collaborations I know that has also been established is with for example, ABB, so sort of industrial automation and robotic experts. Do you ultimately see the gigafactory as a highly automated space? We're going to come back onto the labor opportunities in a moment, but will it be a highly automated operation?
Yes. We have actually eyeing two scenarios. I mean, first a low automation, but also a high automation scenario. And well, I'm very friendly with creating jobs, but for sure from the financial perspective, we also need to look into the business and make it work. So a high automation will for sure give us many benefits, but still being a part of a great job creation. We also see a factory like this in this kind of scale is creating 10,000 jobs in the larger ecosystem, not just a direct jobs in the factory. Now we're talking supply chain services around the factory. So it's a huge impact. Even if we go on a high automation, we can see that we're creating 10,000 jobs in the area, which is fantastic, and that's the most important for us to be a part of, and extremely rewarding to be a part of creating such opportunity.
Great, and then we actually have a few questions that have come in on that, what I'll come to shortly. Maybe a last question to throw to you, Lars, and then I'll bring Daniel in. You've obviously mentioned the important role that the governments will play in this transition, and the mention of Secretary Granholm being there in the US. It's an important signal from the Department of Energy. If we look to Europe, for example, now, and in Italy, what's some of the things you most need and want to see to help help make this transition go from a fanciful target to reality?
I can clearly see that the need for support from government, and it's not talking about financial support. I also talk about believing in these projects. I mean, we have seen in Italy, we have a capex of 3.5 billion euros, which is massive. And from Italian perspective, it has been a lot of questions around this. Can you really source this kind of funds? Is this for real? Can it happen? Because in Italy, we have an old tradition that is only big corporations or banks who can do these type of projects. So therefore, it's been a bit hard to explain, and also explaining how the market is, and also explaining that this is actually a new time. It's a new industrialization which haven't happened in 100 years. And from that perspective, it's been tough. And therefore, I see also governments can be more updated on what's really going on, as they also are a part of the transition. So therefore, I really encourage governments to take more active role in the process, and also understand what's going on in the world, because many of them are still living in the past here and cannot see that this is a huge change that will change our lives, and they don't really got it yet. So it's so therefore, I think government should be more involved in the processes.
Absolutely. I'm going to use that as a cue to bring Daniel Harrison back into the conversation as well. Daniel, thanks again. You alluded to this in your presentation, some of the different things that are happening. Of course, if we look to China as well, we would see significant support, let's say, for those value chains in the past years. What echoing Lars's point, I mean, where do you see the most active engagement, and where do you think it needs to focus for some of these targets to be realized?
I mean, in terms of government support, you mean?
Yes.
Yes. I mean, we've seen the EU battery regulation, which essentially stipulates that each battery will have to be sourced from local materials within Europe, but also have a battery passport attached to it, I think by 2027, which will have a complete sort of record of its carbon footprint, that it's been produced by, almost like a blockchain showing every stage of its history. So that's a very critical aspect that the European Union is certainly pushing through to drive the regionalization and development of European battery supply chains. So that's a good example.
Yeah, and Lars, I mean, I think, do you think it's going far enough in that case?
Well, no, I think we need to have a more active role in the process itself. It's for sure it's good that we're creating opportunities, and maybe also limiting Asian batteries inflowing to Europe later on, even if it's going to be difficult for the automotive industry to support their manufacturing. That's something we also need to understand, because we have a 45 gigawatt capacity fully furnished, but in 25 we might have 6 gigawatt in production, and that goes for all the other initiatives in Europe as well, which means that we have still going to have a fairly low capacity in Europe, and we will not have enough battery to support the European current automotive industry with batteries. So that's going to be very challenging, and at the same time need to stop the inflow of Asian batteries into Europe. So it's going to be a tough balance and how to make this work. And so therefore I can clearly see that their involvement in these factories has to accelerate even more, because we need the capacity, and we need it now, and it's going to happen in the pace proposed by the governments. Then we need to accelerate a lot more.
And I will start with you on this one, on Daniel. I refer to platform sharing, and what we see, talk about GM and Honda, for example, in the US. We see Volkswagen and Ford on a platform level on some aspects of battery. Is there more kind of competitive sharing that OEMs can do to help in this transition as well, given the capital costs that are there, given some of the uncertainties? Are we likely to see more of that happen?
I think to an extent there will be. I mean, for example, we know that Ford uses the VW's MEB platform for some of its electric vehicles. So there is scope for that. I think at the same time, there's always going to be a competitive advantage gained by developing your own cells, your own pack, your own software to get that critical competitive advantage. So I sort of see both happening at the same time. I don't see a situation where we have a common platform that all OEMs use and then they personalize it with their own brand. I don't see that happening at all.
Lars, what about from your side? If we think about the battery, will it become a space of more shared technology, or as with very clear competitive lines?
Yes, I think it has to be more. The thing is, for the automotive industry, by tradition, we can see this platform had a lifespan between 6 to 9 years. It's not going to now going to be a lot shorter, which means it's going to be extremely costly for the automotive industry to catch up. And the reason for it being shorter, because that's the battery technology will going quite fast, and it's going to be. I mean, if you're sitting in a platform where you have a battery which charges in 40 minutes and the competition have a battery charge in 5, then they need to replace the platform most of the times if you cannot have a flexible platform that can accommodate other solutions. But it's so therefore I foresee that they're going to be a lot more. Well, I'm not sure that all OEM will survive this. It's going to be extremely costly, and I'm not sure they're gonna make it. And also, I mean, the whole transition is gonna hit very hard on unemployment. It's a lot of jobs will be lost. They're talking about millions, and so therefore we also need to ramp this up and to accommodate all these people that will be unemployed going forward, because the combustion engine, as we all know, have a lot of bits and pieces. The electric car doesn't have it, and therefore I can only see in our part in Piemonte we're talking about 60 to 100,000 jobs in a short period of time, and I can see in Europe it's millions of jobs that will be lost in this process. So therefore we need to ramp it up and make sure that we can offer new jobs for these people in gigafactories, for instance.
It's an important point, and one I almost feel we live in a strange contradiction of times. You kind of alluded to it, Daniel, but I mean, the moment in the automotive industry and many industries, it feels there's labor shortages at every turn. But at the same time, as you're saying, Lars, there's many aspects of, well, be it the potential downturn we're facing, but also more critically, the structural changes in the industry. Do you think, you know, that battery production gigafactories is the important way to counterbalance that? And then I'll follow up on the skills. So firstly, but is that how you see it, Lars? That actually, as the jobs decline in one bit, that the gigafactory has the opportunity to capture it?
Yes, they can. Not the factory itself, but the supply chain around the factory. I mean, the giga site around the factory will recover a lot of these jobs. And as mentioned also for our project in Italy, in Piemonte, it's 10,000 jobs. So I mean, it will recover a lot of these jobs actually that will be lost. And so from that perspective, I see it as a solution and something that could for sure ease this kind of pain and also economic downturn, having all these people unemployed. And also when we're talking about well, it's true also that we have difficulties these days to find workforce, but I mean, we're talking about extremely qualified workforce like engineers and technicians and so on. But here I'm talking about blue collars, and that will be the big problem going forward.
There's a question from the audience, I guess, kind of referring to those high-skilled areas. The question is there a plan or program to work with local universities to create high-skilled engineers to generate job opportunities in the Imperial Valley? So that's referring to the State Vault facility. But I think we could extend this question as well to Italy as well. So is that an important part of your plan?
Yes, we have collaborations both in the US and also in Italy. In Italy, we just closed an agreement with Milano Politecnico, and which is establishing a project on recycling and minerals. But it's also it will be extended into education and also for on the high level. And but also we are setting up a program, a battery academy, where we will also inviting young kids, 16, 17 years old, to be a part of the battery academy, to be the future worker of the factory. And similar projects are ongoing in the US also with the University of San Diego, for instance.
And we have a question here. Daniel, I might start with this one to you. The question is, how important is a LCA, life cycle assessment, for gigafactories? I guess how important is it? How important will it become?
Well, as I was alluding to in terms of the European battery regulation, very important, because ultimately they will have to prove that they can produce and manufacture the battery cells and the wider supply chain and become carbon neutral. I know CATL, we interviewed them recently for their first carbon neutral gigafactory. So that's a very significant move in that direction. And I think, for them, Lars talked about, Asian batteries coming into Europe and that being overwhelming in terms of volumes, and when we need to regionalize the European battery supply chain. And one of the reasons CATL are creating that carbon neutral battery plant is so that come that point when that battery regulation kicks in, they will be able to supply to the European Union as an Asian manufacturer, either at their German plant in Erfurt, I believe. But it's a case of, I think all of the supply chain will have to become carbon neutral and fulfill that life cycle assessment.
Yeah, and Lars, I mean, again, going back to that figure, 1% of all energy in Italy, possibly. So clearly, when you put that into the context, I mean, these facilities will, and then taking the supply chain, we have an order of magnitude. If not looked at from a life cycle point of view, would become tremendous centers of energy cost, emissions, etc. if it wasn't then looked at. So I'm guessing for you, this is really at the heart of some of the business models that you're proposing.
Yes, I mean, that's why we're also being forced to take an active role in the sourcing of energy, and which actually map us more into being a part of a chemical company, but also being a half energy company at the same time. So we need to involve ourselves in the energy space a lot more than we probably anticipated initially when we launched these projects. So we can clearly see that we need to take an active role in the creation of energy, or at least understanding where this energy will come from and support these processes also. So it's a huge challenge, and that's my biggest concern, is the energy, especially green energy, because it's going to create massive problems. And also, as you see, the rise in the cost of energy will probably be crazy this winter to start with, and this is something that's not gonna leave us for a very long time. So we need to live with a new reality, and therefore we need to find new energy resources and try to understand how we can balance this in a more proper way.
Well, an ICE powertrain may be more complex mechanically, but I think these points show, if you're going to be in the EV powertrain space and the battery space, you, as Lars alluded to, you need to be a chemical company, you potentially need to be an energy producer in your own right. So the complexity of this is certainly significant. But another audience question that we had, so obviously we were talking about battery cells and packs being imported from Asia because of lack of capacity, potentially that increasing at least until the production goes up. But this question is actually, looking at some of the equipment as well. So the question, or at least the statement, is it would be good to analyze the sourcing for equipment related to gigafactory battery plants, because today a lot is also imported from Asia Pacific for current cell manufacturing. So that point there, that it's also holistically, it's not even just the cells itself, but I think to actually produce this equipment. And I know from speaking to Volkswagen, for example, who of course are building up a gigafactory in Salzgitter and elsewhere, but they're relying quite a bit on what's happening in Goshen in China, and where they're already obviously ahead. And you definitely, it's not as simple as turning a switch on in Germany. So I think, again, Lars, just if there's anything you wanted to add to that comment around the working with your partners, for example, to localize other aspects of that production too.
Challenging with the machine and equipment, and a lot of these producers are in Asia and China, but also high risk that you receive equipment that is not really valid when you have it all installed also. We have very interesting collaborations in Germany currently, where we see a totally new generation of cell manufacturing equipment, which create less scrap and also been more efficient, and also more energy efficient in that way. So it's really interesting things what's happening now. I can see the new engineering equipment that's now coming in Europe, and especially in Germany, are probably 5 years ahead of the equipment that you can find in Asia currently. For sure, it's going to be more expensive, but you're going to earn them back a lot faster as it creates less scrap.
Absolutely. So yeah, we're really important point there. I mean, we're coming close up to the hour here, but I wanted to just maybe one or two last questions for our experts here. So, and this relates to actually another question that came in on the audience. So do you think, I mean, rapid changes in chemistry and technology, whether that's the cell design or even new things like solid state, could this either disrupt the capital investments and the current kind of planning that we're talking about here, or as one of our audience member puts it, is something like that, solid state, actually an opportunity for Europe or the US to move ahead from where perhaps they're behind in places like Asia? So again, that's not an easy question to answer, but I'm interested. Maybe Daniel, I'll start with you and then come to Lars on that.
Yeah, that's a really great question. And what we're gradually seeing is there's a clear sort of so essentially for base level, entry level vehicles, OEMs are starting to choose LFP chemistry because it's cheaper. It's less
lithium phosphate.
Lithium phosphate, sorry, yeah, LFP, and it's cheaper. Although it has less energy density, therefore it means a bigger, heavier battery. It makes more sense to bring the overall cost of the EV down. Next up is probably the most common, which is NMC, nickel, manganese, cobalt. Higher up would be sort of for premium vehicles, NCA, so nickel, cobalt, and aluminium, and that's used by Tesla. And at the very high end, you're likely to see, in very sort of niche high-end cars, you're going to see the solid state come in. But remember, that's also a lithium technology, so it's just replacing the liquid electrolyte with a solid material. So I don't see a fundamental shift in the gigafactories, the processes. So therefore, very little risk in investment. It just means the chemistry is going to constantly evolve.
Yeah, as you said, which we're already seeing. So, Lars, anything you would add to that?
Yes, I mean, we've been also working very hard on this. We also clearly see that the technology will advance very fast in the next 10 years. And we try, as this is a very heavy investment for 3.5 billion, we also see that we need to future-proof our factory. So we created a modular factory, which many are for sure doing. And this also gives a lot of flexibility, and we can have multiple technologies also ongoing. And also trying to create it or engineer it in that way that we can easily change the technology without being too costly of the equipment or in changing the building. So that's something we're trying to foresee and trying to eliminate the costs for a future scenario where the technology changes significantly.
Great. Well, just a last question, and the answer might seem obvious, but I don't think it is so obvious necessarily. And it's really just, well, what will success look like in 5 years in this space, in EV battery and production? Clearly, you know, there's lots of plans around ramp up, but what, Lars, what for you, for your companies, what will success look like in 5 years?
Well, for sure, I hope, well, first I'm going to start with a hope for. I hope that all these projects in Europe will at least be able to start some kind of production. That's the most important thing, and it's a good start. But as said, the transition will take longer, and we will for sure be well ahead, and we are taking the first very important steps. But I also see close collaboration with the automotive industry, with the OEMs, and being a part of the various processes, and also trying to find some kind of standards. I don't see that we can have 10 different type of standards, and this is far too costly. I foresee maybe 2 to 4 technologies. Otherwise, it would be too costly for the automotive industry to use these products, and it has to be some standard going forward. And this is going to take some time. And eventually, in 5 years' time, we probably or hopefully have created some kind of standard within the industry.
Great points there. So obviously not just about getting those operations going, but really about seeing some changes in standards in the industry as well. Daniel, any last thoughts about what success will look like in 5 years?
Yeah, I mean, for me, it's about the constant evolution in battery technology. You know, I think the pre-COVID there was a constant downward trajectory in terms of costs. I think at one point it reached as low as $120 or so per kilowatt hour at the cell level, that is. We've seen obviously a spike recently with raw material prices. I calculated it's gone up to something like 200 kilowatts an hour, which I estimate adds cost of around $4,000 to $5,000 per vehicle for an average battery pack. So, and there's often this talk about, okay, once it reached that magical $100 per kilowatt hour, then you have price parity with ICE powertrains, and that's when you'll get the mass consumer transformation, realizing, okay, the total cost of ownership is considerably lower now, the purchase cost is the same. Then you'll see that huge transformation and a huge ramp up in demand and acceptance. It will become mainstream. That's for me where the success comes.
Fascinating. It's going to be quite a journey, and it has been even for me for the last hour. We've covered so much, but I want to thank both of our experts today. Lars, thank you so much for sharing with us, and really looking forward to talking more with you about this, including as you establish those partnerships and get going. I'm going to tell our audience immediately about the really important opportunity to connect with Lars with us, but also Daniel, many thanks to you, and again for this insights and for tolerating you know, my demands from Mr. Battery, and again to our audience to make sure you download those slides and indeed check out that battery report that Daniel has just done. I think you'll really enjoy the data that comes out of that, but also just to you know, let everybody know, we'll put a link into the website on this. We will be connecting in person, hopefully with many of you, and indeed with Lars Khalsam. Lars Khalsam will be among our speakers in Munich in December this year, December 7th, where we're talking about scaling up EV and battery production, the flexibility, automation, digitalization, and partnerships that will support that. I'm very excited to bring this event to you, and really hope you'll join. As some of the experts already we know who will be joining us there, and there's a lot more we're building and planning. So you know, we're really covering many aspects of the value chain, going inside factories and looking at processes, but clearly looking at the strategic side of what this transition means as well. Lars highlighted that very well in terms of what needs to happen, and so we're going to spend, it will be a packed day, and there'll be some great stuff alongside it. So I hope you'll consider joining us then. It'll also be streamed online, but please do join us if you can be in Munich in December. Maybe we'll take a jaunt to the Christmas market as well in the meantime. But so that's an upcoming opportunity, and you know, also we'll be back with the Automotive Livestream series continuing after we'll take the break in August, but we're back in early September talking about startup manufacturers. And the question, are all OEM startups now really? You know, clearly we have brands which are launching new products but partnering with others, but you know, as we talked about in this whole last hour, so many new processes involved. It's really in reinventing many areas of production, value chain, supply chain, logistics. So hope you'll join up. The link is coming at you. You can sign up already for that today. We're supported by ArcelorMittal for that, and we'll be bringing an exciting program to you then. So that's September 8th. And I can't recommend it enough, if you're in the Detroit area in the end of September, consider joining us for Automotive Logistics and Supply Chain Global. This is our automotive logistics brand, talking about automotive logistics with GM, Stellantis, Nissan, looking across all the disruptions we see, of course, in the supply chain and the competitive changes that need to happen. Of course, we'll talk a lot too on the EV and battery side. So again, more links coming your way. We're trying to plan out your next couple of months really for you. That's the idea. But again, mostly we hope you'll enjoy it. You'll join us in December. That's really it for us here today at AMS Automotive Evolution live stream. You can find this other live streams on the page, which you can see listed there on our website, and register for upcoming events. Look at, check out the past events which we had on demand. This very event will be available by tomorrow latest. So if you've missed anything and you want to go back and check it out, do it there. You can download the slides right here or from our website then. So again, look forward to seeing you. It's been really great for me to host and to share these insights with all of you. So once again, big thanks to Lars, big thanks to Daniel, and thanks to you for joining us, and look forward to seeing you at the next live stream or event.